alkyl halides are colorless. Okay. This would be what? Colorless. But then certain compounds of bromine and iodine may possess color. Okay, different colors would be there. And many volatile alkyl halides. Volatile means, do you know? Have sweet smell. Right? This is very basic
Yes,
physical
ma'am.
properties. It's about the appearance. Volatile means what? Yeah? Yes, Aditi? What do you mean by volatile in nature? If suppose I said this liquid is volatile in nature.
It's easily evaporated.
Easily evaporate. Very good. Means its boiling point is very less. If you keep open into the environment, it absorbs the energy from the environment and convert the surface molecule into its gaseous state. Correct?
Yes, ma'am.
Yeah. The next is what? Melting point and boiling point. Right? So, first of all, if we see about the melting point and boiling point of your alkyl halides, RH with compared to your RH. What are the RH? RH is hydrocarbon, correct?
Yes, ma'am.
RH is what? Alkyl halide.
Ma'am, since RH bond is more stronger, the boiling point will be higher, right?
Sorry?
Since alkyl halide, the bond is stronger, the boiling point would be more higher, right? Comparatively.
Yes, yes. Melting point and boiling point both with respect to the alkyl halide would be high as compared to hydrocarbon. Why it is so? Because polarity of the bond. Correct? Polarity means it has a positive delta charge on it, it has a negative delta charge on it, and as the electronegativity, size of the atom or size of the halogen and number of carbon atoms increases, what happens? Your boiling point and melting point is also increased, even with respect to the number of halogen atoms as well. Understanding?
Yes, ma'am.
Yeah, so this is very basic physical properties, melting point and boiling point about. With respect to the same alkyl group, what would be the trend with the halogen group? If we see, so suppose R would be the same alkyl group and it is attached to the iodine. It has a more boiling point as compared to bromine, substituted alkyl halide. It has a more as compared to chloro or chlorine substituted alkyl halide, and it has a more boiling point as compared to chlorine substituted alkyl halide. This is due to the size of halogen group, right? Size of iodine is greater as compared to bromine, bromine is greater as compared to chlorine, and chlorine is greater as compared to chlorine. This is with respect to what? Same alkyl group. Okay? Clear?
Okay.
Fine.
Yes, ma'am.
Fine. What about Chandana? Where is she?
I have no idea, ma'am.
Okay, fine. Let it be. She'll join, hopefully. Let's see. Now, we are going to see about the isomeric haloalkane. Isomeric haloalkane. I'll ask you to write down the isomers of this. 2 bromo, 2 methyl propane. Two bromo, 2 methyl propane. Means what? At the second carbon, what happens? At the second carbon, bromine is also present and methyl group is also present. And there would be propane, means straight chain must be contain how many? Only 3 carbon. I guess this would be the compound. And its boiling point in a Kelvin would be 346, where its isomers must be having this one, CH3, CH2, CH2, Br. This is N-bromopropane. N-bromobutane. It won't be propane. It would be butane, because it must be consist of 4 carbon. Correct?
So it will have higher boiling point.
Obviously, why it is so? That's what
Because
I'm
there is
asking.
less number of branching.
Yes. Yes, bromobutane. Okay, it won't be propane, it is a butane, and its boiling point is 375 Kelvin. And the next, another isomer of this will be what? CH3, CH2, CH, CH3, and this would be attached with the bromine. This would be what? 2-bromobutane, correct? Yes.
Yes. Yes.
What would be the boiling point for this? 364 Kelvin. Now check the values.
As the branching decreases, the boiling point increases.
Yes. What you come to know? 364. Yeah, check this. Values. In which substance more branching is there? In this, correct? After that, here. And then least branch or normal butane is nothing but this, right? So it's a straight chain compound. There is no branching. It has a high BP, right? Here is a little branching increases. Well, the boiling point would be decreases. And here more branching is there, and hence you have a least boiling point as compared to rest all isomers, okay, with the same molecular formula. Clear? So what you have to keep it in your mind, as the branching increases, boiling point decreases. You can say it's inversely proportional to each other, right? Yes?
Yes, ma'am.
Fine. Shall I erase it?
Yes, ma'am.
Yeah. Now we are going to see about the boiling point of isomeric dihalobenzene, right? I'll write it here, isomers of dichlorobenzene, okay? This would be your
Okay.
benzene, right? This is your first chlorine. This is your second chlorine. What would be the name for it? You have to tell me. I'm going to write another structure over here. This is also benzene. This is a chlorine.
Ortho, meta, and para.
Yes. Among that, you have to tell me what is the sequence of the melting point and the order of the melting point and the boiling point in this. And why? Reason also you need to tell me. If you don't know, then I'll definitely going to tell you. Fine. If you don't know, that's fine. Now, if you see the boiling point about this, boiling point of isomeric dihalobenzene are very nearly same, and somewhat same. There would be the minor differentiation in between, like hardly of 1 or 2 degrees or 2 or 3 degrees, right? Not much. But then yes, about the melting point, there is like a lot of difference, noticeable difference, right? And why it is so, that you need to keep it in your mind. Why?
The
Already
sequences ortho, meta, and para.
I'll write it here for the boiling point. 453 Kelvin. This is 446 Kelvin. This is 448 Kelvin, correct?
Yeah.
Right. And now for the melting point, in Kelvin it is 256, 249, and this will be 323. So you can check this is 453, 446, 448. So it's not much differ, right? Nearly same.
Yes.
But then for the melting point, noticeable difference is there. For ortho and meta, there is little similarity, means they are somewhat same. But then para, melting point
It
is
is the highest
why it is so?
because para is symmetric.
Yes, it is symmetric. We are able to cut it into half, right? In this way, you can cut it into half. In this way, you can
Yeah.
cut it into half, right? In this way, you can cut it into half. In this way, you can cut it into half. This is due to high symmetry. It is very difficult to break the bonds, right? So higher order of
Yes.
symmetry of the para isomer make it more stronger, and hence it require more energy to break its bond and convert into liquid state. Fine. And hence its melting point is high. Clear?
Yes, ma'am.
Fine. Now next one would be about density. What about this? Now you can check bromo, right? Then iodo and polychloro derivatives. Polychloro means more than one chlorine derivative. Okay. Of hydrocarbon are heavier than the water. They are heavier than what? Water. Fine. So density increases with increase in the number of carbon, with the increase in number of halogen, and increase into the molecular mass of that particular alkyl halide. Okay. Density is increases by 3 points. First one, by the number of carbon atoms present into the compound. It may increase by number of halogen, okay, halogen atoms present into the compound, and it may increase by what? By the molecular mass. Okay. So these three things you need to keep it in your mind about the density. Clear?
Okay, ma'am. Yes,
Fine.
ma'am.
And next about what? Solubility. That rule you know, like dissolve like. Yes. This rule you know or not? Yeah. Aditi. Hello.
Yes, ma'am. I know. Polar dissolves in polar solvents
Yes.
and
Yes.
non-polar and non-polar.
Yeah. But then what we know, alkyl halide Rx. What is this, polar or non-polar?
This is polar.
Polar. Already we have learned about the CX bond, right? It's a polar bond. But then it is sparingly soluble into water. How it is? Sparingly soluble into water. Why it is so? Because hydrogen bonding may take place with the halogen, but then hydrogen bonding strength won't be that much to break the Rx bond. Okay, it requires more energy, and that energy will not be provided by the water molecule. And hence, Rx is sparingly soluble into water, means alkyl halide is sparingly soluble into water. Fine. But then if same compound you try to dissolve into non-polar solvent, then it can be easily get dissolved in that. So it is dissolved into, or it is soluble into non-polar solvent. Okay. Sparingly soluble into water. Why? Because water molecule, when try to dissolve it, what? It require more energy to break the Rx bond. It cannot be overcome by the hydrogen present into the water by breaking the bond of hydrogen present into the water, and hence it's sparingly soluble into the water. But then in case of polar solvent, it can be easily overcome, and hence it is dissolved into non-polar solvents like benzene. Then you can say any another hydrocarbon. It can be dissolved easily or soluble easily. Fine. Organic solvent dissolves your alkyl halides. Fine. Clear? Aditi, are you there? Hello.
Yes, ma'am.
Are you writing?
Yeah, ma'am, I was writing.
Okay, fine. So shall I erase it?
Ma'am, just a minute, I need to write the last point.
Yeah, please go for it. Once you have done, we are going to see the reactions.
Yeah,
Right?
ma'am, done.
Fine. Yeah. So now we are going to see the reactions of haloalkane. Right? There are the three main reactions which we have to see. Among that, first one is nucleophilic substitution. Second one would be elimination reaction. And third one is what? Third reaction is reaction with metals. These three reactions we have to see. First of all, we are going to see about the nucleophilic substitution reaction. Sorry, nucleophilic substitution reaction. In that, we have to see two different reactions. Actually, three, but then third one I'm not going to describe now. When we go forward in the chapter, I'll explain you about it. There are the two type of nucleophilic substitution, SN2 and SN1. Okay, while writing also, we should not write in that manner. I'll let you know how you're supposed to write this. It's very important. Like presentation of this. N should be small and here it will be 2. N should be small and here it will be 1. So what is the name of this reaction? Substitution nucleophilic second order reaction or bimolecular. Substitution nucleophilic unimolecular. Right? In this way you're supposed to define it. Right? Substitution nucleophilic bimolecular. And here substitution nucleophilic unimolecular. Okay, fine. Wrote. Have you completed, Aditi, with this?
Yes, ma'am.
Shall I raise?
Yeah.
Fine. Now, what do you mean by the nucleophile? First of all, you should tell me. Already I have explained in the last period about this. Let me know whether
A
you...
nucleophile is a negatively charged molecule which is nucleus loving or nucleus deficient molecules.
No. Electron deficient molecule would be electrophile.
No, I
That
said nucleus, not electron. I said
what you
nucleus.
said?
I said it's a nucleus deficient or nucleus loving
No, it
molecule.
won't be nucleus deficient. Nucleus would be there in that. Nucleus would be there in that. Nucleophile means electron rich species. What do you mean by nucleophile? Nucleophile means electron rich species.
No, actually in NCERT it's given like that. In NCERT
How
nucleo
come?
no, like for for understanding, they give nucleus as a positive charge, so it's positive charge loving, so like it would give away electrons.
Yeah. If nucleus with a positive charge, that would be electrophile. And if nucleus with a negative charge, that would be nucleophile. Clear? In this manner, it's been given.
Yeah, like they said it's a nucleus loving because nucleus we usually consider it as positive, right? So it's a positive charge loving molecule, so it will give away electrons. While electrophile is a negative charge loving molecule, so it's a electron loving molecule, so it will take
Get
electrons.
confused, beta, about like whatever definition is NCERT giving to you. Don't get confused yourself about it. But then I'll let you know what is the electrophile and nucleophile in detail. Electrophile are electron deficient. Okay. Electrophiles are positive species and they're electron deficient. Okay. They are lacking into the electron, and because of that, they are bearing positive charge, like cation, right? But then cation would be for either single atom, right? But then electrophiles won't be single atom. It would be either atom or group of atom. Okay. And nucleophile is also either atom or the group of atom which bear the negative charge because they are electron rich in nature. Okay. Understanding? Nucleophile means what? Electron rich species. What can be the electrophile? Now F minus can be the electrophile, right? OH minus can be the electrophile. Now cyanide CN minus can be the electrophile. Then Br minus can be the electrophile. Our halogens also can be the electrophile because all halogens are electronegative in nature, correct? Yes or no? Hello?
Yes, ma'am.
Yeah, so this is basically you have to keep it in your mind. Electrophiles are electropositive in nature. They are electron deficient. Nucleophile are electron rich species or electron rich in nature. They have a negative charge on it, right? Means they have an extra electron to donate. Whereas electrophile can accept the electron. Okay. What are the characteristics of nucleophile? They can donate electron and form bond. Whereas electrophile can accept electron and form bond. So it will be attack where? Attacked on the electron deficient species. And it will be attack where? It will be attack on electron rich species. Understand? Yes or no? Nucleophile will attack electron deficient species. And electrophile will attack on the electron rich species. Clear? Yes?
Yes, ma'am.
Fine. Shall I erase it?
Sure, ma'am.
Fine. Now, what do you mean by the nucleophilic substitution? First of all, you should understand about the substitution means what.
Substitution as in replacing the original molecule in a compound with the reagent, attacking reagent.
Substitution means what? I'll let you know. Suppose there is a compound A and B. Two atoms A and B made a compound, and C is one of the compound which is more powerful than that of the B or A, and it can be displaced or substitute B from its compound and form the compound AC, and your B would be come out, right? So this actually a displacement reaction which you might have learned in your grade 10th, you might have learned in your grade 11th, maybe. And that is nothing but the substitution. Means in this what happened exactly? C is being substituted at the place of B. And you get a AC as a new compound, correct? Yes? Means basically what happens? C displace or substitute the B from its compound, right? And form an AC. So this is the substitution. Now we will come to the term nucleophilic substitution. Means if suppose in a compound one nucleophile is already present and another stronger nucleophile would come and it replace that nucleophile present into that compound is called as nucleophilic substitution. Correct? For example, suppose this is a nucleophile If it in come in a contact with general, suppose this is any alkyl halide, HX. So nucleophile would be electron rich species. Our halogen is also electron rich species which bear the minus delta charge. Your carbon would bear the plus delta charge, because we know already, we have learned about the nature of the CX bond, in which carbon is electron deficient and halogen is electron rich. So this nucleophile will be attack over here on this carbon, and your X group would be depart. Your X group would be act as a leaving group in this. Okay. And what you will get? What you will get? Your carbon as it is, your nucleophile would come, and your X would be depart with a negative charge. This will be called as what? Leaving group. Clear? Yes?
Yes, ma'am.
And specifically what happened? One nucleophile displaces another nucleophile from its substrate to form a new compound. This is what your nucleophilic substitution. So the reaction in
Yes,
which
ma'am.
nucleophile replace already existing nucleophile in a molecule is called as nucleophilic substitution. Fine. Understood? Now I'll explain you about the type of nucleophile. Means like nucleophile would be a simply electron rich species which can donate the electrons, right? And displace the another nucleophile. But then there are the certain another type of nucleophiles which are quite different. For example, cyanide CN, right? With negative charge on carbon. Correct. Now, if this negative charge, I kept it over here as well as a lone pair on a carbon, this triple bond can be shifted on the nitrogen. So it can be converted into what? C with lone pair, carbon nitrogen double bond, and nitrogen would be electron rich. If you see, if I take a CN as a electrophile, sorry, nucleophile, sometimes it may attack with a carbon, sometimes it may attack with a nitrogen. Correct? Because carbon also negatively charged in this case, and even nitrogen also negative charge in this case. Such a nucleophile which have more than one donor in the in their like what we can say nucleophilic substance, that is called as ambidient nucleophile. What does it called? Ambident nucleophile. Because it can donate the electron from both ways, either from carbon or either from nitrogen. Similarly, one more is there, that is nitrile group, nitrogen, double bond O, and here oxygen, double bond O, sorry, single bond O. Either double bond also you can say, but then that double bond can be converted into negative charge by giving the electrons towards one of the oxygen. You will get O minus nitrogen with lone pair, and here oxygen. Clear? Understanding means in this case also, this nitrile group can be attacked with oxygen, can be attacked with nitrogen. In both way, it can donate the electron, and hence it is also your ambidient nucleophile. Okay?
Yeah, ma'am, got it.
Got it? So now suppose somebody asked you what is ambidient nucleophile. Can you tell?
Yeah, it is a nucleophile which can donate an electron either from like any other atom or the carbon. Like any
So group like
electronegative atom.
cyanide and nitrile, group like cyanide and nitrile possesses two nucleophilic center. One in the cyanide it would be either carbon and nitrogen, and in the nitrile it would be oxygen and nitrogen.
Nitrogen.
And then, yeah, such a nucleophile is called as what? Ambidient nucleophile.
Ambidient nucleophile.
Clear? Which have more than one nucleophilic center. Fine.
Yes,
Shall I
ma'am.
read?
Yeah, ma'am.
Now we are going to learn about the SN2 mechanism or SN2 reaction. What it is? Substitution, nucleophilic, bimolecular. Fine.
Yes,
So
ma'am.
first of all, you should know the reactant in this case. So in this case, reactant would be what? Methyl halide generally, or methyl chloride you can take. When react with your hydroxyl ion. Hydroxyl ion means OH minus, correct? That won't be
Yes,
freely
ma'am.
available. You have to take either water molecule, you have to take either NaOH, right? Caustic soda. In that case, you will get what? You will get what? Methanol, because OH or this hydroxyl group will be attached to methyl chloride and chlorine would be depart. Right? This is a general reaction. Right? Generally, I have written in this manner. So, in this case, what happened? This reaction is called as SN2 reaction for what sense? Why it is SN2? Right?
Ma'am, because
Why
it
it
like
is?
attacks from, it's a bimolecular reaction and it attacks from the backside of the substrate.
No, it's not because of that SN2. This 2 is related to the rate of reaction.
Yeah, it is but there's only one step, right?
Yeah, it's related to rate of reaction. Why? Because rate of reaction is depend upon both the substrate, methyl chloride as well as your hydroxyl ion. Understand? And because of that, it is a second order reaction. And hence, it is bimolecular. Though it follows only one single step.
So like
Right?
we can, but there are technically two steps, but one of the step is transition state, right? So we don't count it as a step.
Yes. Actually, SN2 reaction is a one-step reaction. In that transition state is occur, but then we cannot isolate it. It's really very fast because
Yeah.
in that state bond making and bond breaking takes place simultaneously, right? And why
Yes.
we are not able to isolate it? Because it consists five like bonds, and for the carbon it is quite impossible to form a five bond because its valence is only
It's
five. So,
highly unstable.
yes, and
So
because of that, we are not able to isolate and we cannot consider it as a step. Fine. So if I write it here methyl chloride, how I'm gonna write? Okay. Carbon. Okay. On the plane of paper, I'm going to write Cl. Purposely, I'm telling you where I'm gonna write. It is on the plane of paper. One of the hydrogen would be on the plane of paper. Another hydrogen would be below the plane of paper, right? And one more is that is towards me, above the plane of paper. Correct? So this is your what? Methyl chloride. Understand this bond's meaning. If it is normal, so a normal line, that is what? On the plane of paper. If it is shown by the dotted line, it is below the plane of paper. And if it is solid
and the
wedge,
dark wedge is
yeah,
towards the viewer.
yes, yes, it is towards us, right? Means out of the paper. Okay, fine. Now what happened in this case? If you add any OH minus would become over here. It won't attack from the same side of chlorine. Why? Why OH minus is
Because
shown here, not this side?
ma'am, because that side is too bulky.
No, not the reason. I'll let you know why it is attacked from the opposite side. Because it's a chlorine, it is with negative charge, minus delta, right? OH minus is also negative charge. So there would be negative, negative repulsion.
Repulsion.
Okay, and
Yeah, and
because of that, it
also
goes opposite side. Clear?
yeah,
When
and
it
also the
goes,
opposite side, like it would be easier to replace because like
yes,
the hydrogen molecule, it's a smaller molecule comparatively with chlorine.
yes. Now what happened? This OH will attack over here on this carbon and your chlorine start depart. Correct? Yes or no? Now you will get a transition state. In a first one step only, you will get the transition state. What it will be? Your all carbon would become on the plane of paper. where it will become on the plane of paper, means you have to show it with a plane line. No solid waste, no dotted structure, correct? But then dotted lines you have to show for what? Your incoming OH group and your outgoing Cl group, right? And this is a transition state, right? This is a minus delta. This is also minus delta. This bond making COH or CO bond making and CCl bond breaking would be takes place simultaneously. And it has how many? What is the valency of carbon actually? 4. It in this, what is the valency? 5. 1, 2, 3, 4, 5. And hence it is highly unstable. Right? It is
Yes,
highly
ma'am.
unstable. Correct? And cannot isolate. And finally, what happened? This chlorine would be depart, and you will get what? The compound with opposite configuration. Right? Means OH would come over here. How Cl was on a plane of paper, in that same way, it would be on the plane of paper now. Right? Now, another 3 hydrogens. One hydrogen would go on the plane of paper. Another would be below the plane of paper. And one towards you. Now, if you see this compound and the previous one, the configuration is totally inverted. It's just like in a heavy rain, how umbrellas turn up inside out. Correct? Yes or no? So in that way, your configuration is completely rotated. Fine. Earlier, chlorine was here. Now this side it is OH, totally opposite side of the chlorine. And these 3 hydrogen groups, those were at the left-hand side of mine currently. Maybe your right-hand side or left-hand side, you check. Okay. In the product, it would be right-hand side towards me. You might have understand what I'm going to tell you. Clear? Aditi? Hello?
Yes, ma'am.
So what you got here? Inversion of configuration.
It's Walden's inversion, right?
Yes. What you said?
Walden's inversion.
I'm not able to hear you.
It is called Walden's inversion, right?
Now, it's an inversion of configuration, beta.
Yeah, that's what it has, that name, right? After the scientist Walden.
Yes. Now, apart from that, one more thing I would like to tell you in this. This transition state is stable when methyl chloride or primary group would be there, or primary alkyl halide is used in the SN2 reaction. When you use secondary, that time what happened? Suppose here you take a secondary, means what happened? One hydrogen would be replaced with CH3 group, right? Only 2 hydrogen would be there. So your transition state become more bulky, right? Steric hindrance in this would be increases, right? And hence it become more unstable and your product yield would be less. So reactivity of secondary halide in the SN2 reaction is less as compared to primary halide. And the same way it would be less for tertiary as well. You can check. Right? This would be the tertiary halide. When you increase CH3, CH3, CH3 3 times, what happened? Number of atoms would be here, what? 3 carbon, 9 hydrogen, then 1 oxygen, 1 hydrogen, and 1 chlorine. So it would become more bulky and it is very difficult to isolate and even difficult to form. And hence, due to steric hindrance, it will not undergo SN2 reaction. Clear? Hence, the rate of reaction depending upon the bulkiness of transition state. And even rate of reaction is completely depend upon the both the reactant, your nucleophile as well as your substrate or alkyl halide. Hence, it is called as the bimolecular nucleophilic substitution. Clear? Shall I erase it? Have you wrote?
Yes, ma'am.
Fine. So here, write down about the rate of reaction. rate of reaction for SN2 is equal to, it depends on concentration of nucleophile and concentration of alkyl halide. And because of that, this is bimolecular. Fine? Clear? Any problem, any query, whatever I taught in that? If it is so, please let me know. Come on, Aditi. Any point if you are not clear about, let me know.
No, ma'am. I got it.
Okay. So 2 minutes are remaining. Shall I close the class then?
Sure, ma'am.
Yeah. So on Sunday we will come with the content of. We will meet with the content of our electrochemistry. Till the time, meanwhile, whatever classes would happen, I'll try to finish this chapter. Okay.
Okay, ma'am.
Fine. Shall I end the class?